So this video is going to run through how we go about testing a scientific hypothesis and what the process is and how our methods might work. So I'm going to set up a hypothesis, and this is based on using the mobile phone colorimeter experiment and to work at home to measure different colours of things. So the hypothesis that I'm going to test in my experiment is what I'm going to do is I'm going to compare two different tea bag brands and to find out whether they make the same strength of cup of tea. Okay, so in order to do this, I'm going to set up a formal hypothesis, which is to say that two different brands of tea will give different strengths of tea. Okay, so what I'm looking for is to eventually be able to draw a graph that looks something like this. So if I've got my, if I've got a graph, okay, so if you remember on the x-axis we usually put the independent variable, which is sometimes called the treatment variable. And on the y-axis, we usually put our dependent variable, which is sometimes known as the response variable. Okay, so that's the thing that we're actually going to measure. Okay, so in this case, if I've got two different brands of tea, so let's just call them A and B. Okay, those are going to be my independent variable. Those are my treatments, is the two different brands. And then on the x-axis, on the y-axis is the thing that I'm going to measure, which in my case is going to be colour of the tea. Okay, so I need to have, in order to do that, my colour needs to be what we call quantified, i.e. expressed in numbers. Okay, so it's no good saying that, oh, that one looks like it's a little bit darker than the other one. What I'm going to need to do this is to actually find a number for expressing my tea. And there's various methods I could do that. And what I'm looking for is to then draw a box and whisker plot. So I've then compared the colours of my two different brands. I can then do some sort of statistical test and ask, is P less than 0.05? If it is, then it's significant. If it's not, then it's if it's greater than 0.05, then it's not significant. Okay, so this is my my experimental question. I've got a hypothesis. So my two different brands of tea are going to give different strengths of tea. This is the type of graph that I'm aiming for at the end of it. So I've got my independent variable is the brand, and my dependent variable in this case is the colour. Okay, so I'm going to base the rest of this on the mobile phone colorimeter method, which there's another video that you can look at on my YouTube channel to have a look at that. Okay, and what this does is, using your mobile phone as a colorimeter, it can give you RGB values which work as follows. So 0 on the RGB scale is black, 255 is white. So all of our values are between 0 and 255 in this method. So it's able to give us actual numerical values for colour for both red, green and blue. Okay, so what we're going to do before we can get to this, before we can get to comparing our different brands of tea, what we need to do is to set up a calibration curve. Okay, so what we're doing is we're testing, what we hope is that stronger T, which was the thing in our hypothesis, will give darker colours. So the assumption we're making is that strength of T correlates with the colour on the RGB scale. Okay, so we're hoping that there's a relationship between the strength of the cup of tea and the colour that we can detect in the colorimeter setup. Okay, so we need to actually test this assumption first, because if this assumption is not true, then we're not going to be able to measure the difference between A and B at all. We need to make sure that this is true. So what we do is to set up our dilution series. So what we do is we set up a bunch of cuvettes, a bunch of dilutions, however you're doing it, with different concentrations that go from 100% to 0% strength. Okay, so in this case, this is the at-home experiment, so the 100% is just a cup of tea. And the 0% is water. Okay, so this is a cup of tea I've brewed for, let's say, a minute in 50 mils of water, and that's my highest strength. Okay, so I know that that is the maximum strength in my experiment, so that's going to colour in, and obviously water is going to be the most dilute. But then we're setting up, we have 80%, 60, 40, 20, 10. We set up a series of dilutions. Okay, so for my 80% will be pretty strong, but not quite as strong as the 100%. 60 will be a bit weaker again. 40 be a bit weaker. 20 a little bit weaker. 10 weaker still. Okay, so I've kind of got different strengths. So I know that these are different strengths. I absolutely know that because I set them up to be different strengths. So what I want to do is to check it on the RGB scale and get the numbers. Okay, so I might measure, so I'm just going to show you for, let's say, the R values. So we might start with a value of, let's say, 47, the maximum is 210, and then we've got a bunch of values, so I don't know, 66. I'm just making this data up. Okay, so we've got a bunch of R values, and we'll have the same for the different colour series. Okay, so what we're going to do now is to draw a calibration curve. Okay, so for a calibration curve, we've got 0% to 100%. Okay, and then we've got the RGB values. And if we do that with the raw data, what we get is a situation like this. So there's our red channel. There's our blue. Again, I'm just making this data up. You would need to experimentally measure this for yourself. So these are just made up data sets. Okay. So if I do that, then I can see that there is a relationship between concentration and the colour that I measure, which is great. That assumption seems to be true. But it's awkward to have what we've got here is an inverse relationship. So just the way that the RGB values work, because 255 is white and 0 is black, you end up with a negative relationship. So this trend line is going down. So for low concentrations, you get high values, and for high concentrations, you get low values. And that's a little bit confusing. So what we would usually do in this situation is to do what we call normalisation of your data. Okay. So the principle of normalisation is a little bit of maths. It's relatively simple maths. So if I now make this RGB norm, again we've got 0% to 100%. If we do a little bit of maths, then we can flip that graph the other way up. So we've now got our three channels. As I say, this is made up data. You'd need to experimentally measure this for yourself. Okay, but now we've flipped it, so we've got a positive relationship. And that's much easier to work with. So now low concentration values have low normalised RGB values and vice versa. So that's much more straightforward to deal with. So in this case, the normalisation, the formula that we've given is, so R norm equals 1 minus R over 255. Okay, so 255 is the maximum that it could possibly be. You can't have values higher than that. R is our raw red value. So this bit of the formula is basically asking how close to the maximum value are we, and then the 1 minus flips it over. Okay, so if we do for pure white to start with, okay, so our norm is going to be 1 minus 255 over 255. So this is the whitest it could possibly be. That's the same thing as 1 minus 1 equals 0. Okay, so I flipped it. So white used to be 255, white is now 0. Okay, and I can do the same thing for black. Okay, so our norm equals 1 minus 0 over 255. That's 1 minus 0 equals 1. So I've flipped the scale so that on the normalised scale, white equals 0, black equals 1, and therefore all my experimental values will be somewhere between 0 and 1. So that's going to be much more easy to work with. Okay. So once I've done this calibration curve and I've checked that there is a good relationship between concentration of my dilution series and my RGB values, now I can go and make different cups of tea with the 2 different brands. I'll need replicates, so we're suggesting n equals 5 as a minimum. Okay, so I can go and do different replicates, I can make my measurements, and then I can go and perform some statistical tests on that data, and there are other videos about the statistical tests to see whether there genuinely was a difference or not. Okay, so that's how I've set up my experiment. This is the hypothesis that I'm testing. I'm looking to see, can I detect the difference between 2 brands of tea? I'm going to use colour as my dependent variable, but I need to quantify it. In order to quantify it, I'm using the mobile phone colorimeter, and there's another video about that. I'm setting up a calibration curve, and there's another video about that goes through this entire process of how to actually set it up. I make up a dilution series. I check that my dilution series does give me appropriate graphs, so I have got a nice relationship between the concentration and the RGB value. I've normalised it to make the data a bit easier to handle, and then I can go and test my different cups of tea.